AI training involves teaching a machine learning model to make decisions or predictions based on data, and it typically begins with the collection and preparation of relevant data. Data must be cleaned, organized, and often labeled in order to train the model effectively. This training process is driven by various machine learning techniques, including supervised learning, unsupervised learning, and reinforcement learning. In supervised learning *, the model learns from labeled datasets, where each input data is paired with the correct output, allowing the model to make predictions by learning the relationships between them. Unsupervised learning *, on the other hand, focuses on identifying patterns in data without labeled output, which helps uncover hidden structures such as clusters or associations. In reinforcement learning *, the model learns by interacting with an environment and receiving feedback through rewards or penalties based on its actions, similar to how humans learn from trial and error. Once the data is prepared, the model is trained by feeding it input data and adjusting internal parameters to minimize errors, which is typically done by optimizing a loss function. The loss function quantifies the difference between the model's predictions and the actual outcomes. Training algorithms like gradient descent are used to minimize this error by iteratively updating the model's parameters. This is a highly iterative process, where the model repeatedly adjusts its internal weights to improve its accuracy. Once the model has been trained and validated, it can be deployed for practical applications, whether it's making predictions, classifying data, or automating decision-making processes. Continuous monitoring and retraining may be required to ensure that the model remains accurate over time, especially as new data becomes available. Thus, AI training is not a one-time process but rather an ongoing cycle of data preparation, model refinement, and performance evaluation.